Okay, so good morning. Well, it's 2:36. Oh, who's they? You're the only one that subscribed. All right, so we did this rewind, we did this proof. We're going to start talking today about coordinate proofs. So I think you guys will like coordinate proofs because you don't have to do them in 2 columns. Coordinate proofs also are probably familiar to you guys because you have spent a lot of time working in the coordinate plane. What is the coordinate plane?
X and Y.
The x-axis and the y-axis, right? And so when you do geometry in the coordinate plane, it's essentially just giving you units of measure. Instead of saying like 10 feet or 10 yards or whatever, we're just working in units on the coordinate plane. So when you put something on the coordinate plane, if it takes up 6 boxes, like this right here, would be a line segment with a measure of 6. Okay? So when you have to position a figure in the coordinate plane, you're positioning this, will give you directions like position a rectangle with a length of 8 units and a width of 3 units in the coordinate plane. So essentially all you're doing then is drawing a rectangle in the coordinate plane that's 8 units long and 3 units wide. You can do it anywhere you want in the coordinate plane, but typically I always put one of the vertices in the origin. All right? Yeah, so at 0, 0, because it just makes the coordinates a lot easier. So if I say this and I want to do a rectangle that is 8 units long, where would another vertex be?
On that side. 0, 8. On the right side. No, 0, 8.
One would be at 0, 3.
And the other one's on 0, 8.
And the not 0, 8.
Negative 8, 0.
8, 0. 8, 0. And then where would the last one be? 8, 3. All right, so this is a rectangle with a length of 8 units and a width of 3 units. So then this coordinate again is 0, 3. This one is 0, 0. This one is 8, 0. And this one is 8, 3. What's the area of that rectangle? 24. How? Because 3 times 8 is 24. What's the perimeter of that rectangle? 22. You're right. It's 22. Really overwhelming. Guys, perimeter is 22. Because if this is 8 and this is 3, what do you do to find perimeter? Add up all the sides. So 8 plus 3 is 11. 8 plus 3 is 11. So I might need to ditch this recording. All right, so 8 plus 3 is 11, and 8 plus 3 is 11. So altogether, our perimeter is equal to 22.
Wait, but I thought 8 was the area.
No, 24 is the area because you do 8 times 3 to get 24. All right, let's back up for just a second. What's the difference between perimeter and area?
You add them all together.
I know, but like what is perimeter? Perimeter's around it, and area is the inside. Okay, so if I said to you, you're building a fence around a garden, and then you're covering the garden in dirt, perimeter would be what? The amount of dirt or the fence? The fence, and the area would be the amount of dirt, okay? So area is all the inside, and you usually get it by multiplying, and the perimeter is all the outside, and you usually get the perimeter by adding up all the sides. Very good. Okay, so could you position this in a different way? Could you position it anywhere else in the coordinate plane? Yes. I put it here because the coordinates then are really easy to figure out. So I always start with one in the origin, but you do not have to. You could position it anywhere you wanted. So you could say, I could put a rectangle right here with 3 this way and then go over to 6. And this would be also a correct answer, but it's just the coordinates are then a little bit more complicated, which is fine. But when we start to do comparisons between them, you want the coordinates as easy as you can make them. Okay. Could you like flip it? Yes. Okay. So to write a coordinate proof then, basically a coordinate proof is just doing some math to prove something right. Okay, so given that the right triangle in this figure, so right triangle ABC, has vertices at 0, 6, 0, 0, and 4, 0, and that D is the midpoint of AC. So I know that D is the midpoint of AC. I want to prove that the area of triangle DBC is 1/2 the area of triangle ABC. So to prove this, all I need to do is find the area of ABC and find the area of DBC and make sure that ABC is double what DBC is. So how do you find the area of a triangle?
Isn't it length times width times height? I'm probably thinking of somewhere.
Base times height divided by 2. Or 1/2 base times height. Those are the same thing. Nope, you don't have to do a 2-column proof. You're just proving it to me using mathematics. So looking at triangle ABC, Gabe, yeah. Looking at triangle ABC, what's the base of ABC? 4. The base of ABC is 4. How do you get that? You count. Okay, it's as easy as that. You just count. All right, what's the height of ABC? 6. The height of ABC is 6. So then to find the area of ABC, so I'm going to do ABC area. I'm going to do 6 times 4 divided by 2, which is what? 12. Good, because 6 times 4 is 24, divided by 2 is 12. Okay, then to find the area of DBC. DBC is this triangle right here. What's the base of DBC? Still 4. It's got the same base. What's the height of DBC? 3. Where are you getting that?
The middle line.
Okay, so you've got to go straight up like that, which gives you 3 because it goes 1, 2, 3 boxes up. So then the area of DBC would be 3 times 4 divided by 2, which equals what? Is 6 half of 12?
Yes.
Yes, so you've proven it. That's it. Okay, so coordinate proof, you're just doing the math to prove it. So with coordinate proof, you don't need to use 2 columns, but you do need to know area formulas. All right, so you're going to have to use area formulas. These are particularly easy when they give you actual coordinates. We're going to look at some in a little bit that don't give you actual coordinates, that give you variables. Okay? All right. Position each figure in the coordinate plane and give the coordinates of each vertex. So can I get somebody to come up here and do a right triangle with leg lengths? With leg lengths A and B. Go. You have 3 options. I'll keep black.
But isn't it going to be black?
No, it won't be because she. What? Sure, I can, but I think you can do it.
A right triangle. Do red. Girl, line up, brother. A right triangle with legs.
Then why would it go up there?
Hey, man.
You can do it.
You don't have to have a certain length, right?
It does not have to have a certain length. I'm going to put like a little warning that says, teacher does not condone everything students say. All right. Okay, perfect. So that's your right triangle, right? Now, it says the length is A, so where's the length of it? Good. Okay, the length of that leg is A. All right, and the length of the other leg is B.
Maybe this.
Sure. No, this is the hypotenuse, so those 2 are the legs. Yep. Okay, so that's B. All right. Go ahead and take a seat. All right, so if that's the case, do you think the board is recording? I'm recording right here. Okay, all right, so if the length of this is B, then what would this coordinate be? What would this coordinate be? What would this coordinate be?
Wait, which one?
Don't say 0. So yes, technically 0, 5, because that's how long Tiara chose to make it. But all you know is that this is B. So pretend those numbers aren't there. You don't know anything about the 5. All you know is that the length of this is B. So what would the coordinate be? 0B. Not 0B. B0. B0. This would be B0 because you went over B and up 0. What would be the coordinate of this one? 0A. Because you went over 0 and then you went up A, because that's the length of that. This one is still just what? 0, 0. That one's still just 0, 0. So again, this is B0 because you went over B spots, because this is the one that Tiara marked B. So you went over B, but you didn't go up any. So it's not up any, so it's just 0. All right? And then over here, your x-coordinate is 0 because you stayed on that axis, but then you went up A. So that's A. All right? So those are the coordinates of that triangle. So again, like I said, you can position it anywhere, but it's easier to position it if you start with the origin, because if you have something like off in the middle of nowhere, it becomes a lot harder to figure out the coordinates, especially when they're variables.
Looks like a little face.
It does. That one? Yeah, it does. Okay. All right. Who can do this one? Gabe.
Oh, they give him a black.
You have a more colorful personality. Oh, I get it. I was like, I thought that was quite nice to Tiara.
But that wasn't.
Yeah, I realized that.
He just worked.
Like her neighbor.
Okay, so let's start with the easiest coordinate. This one is 0, 0. What would this coordinate be? 0D. 0D. Why? Because it's over 0, but then you went up the measure of D. Okay, what's this one?
0Z.
It would be, except Gabe made it complicated because Gabe went which way? Negative. So this would be negative C, 0. I would have gone that way, and then it would have been C, 0, but that's fine. So it's negative C, 0. And then what's this one? Negative C, D. Why is it positive D? Because you're going up. When would it be negative D? If Gabriel had put the rectangle down here, it would have been negative D. But because it's right here, it's a positive D, negative C. All right? Again, if you had put your rectangle going to the right side, if you had put it going like over here, then it would have been C, D, both positives. Yes. Yeah. Okay. Questions on those variables and how you mark them? All right. Go to your boards and do these 6.